we are continuing to look at absolute value transformations, meaning transformations or changes to the absolute value parent function. On this notes page, we're looking at the effect of a coefficient A, meaning a number outside the absolute value bars, a number being multiplied by the absolute value of x. For all of these transformations, we're comparing our new function to the absolute value parent function. The absolute value parent function is f of x equals the absolute value of x, and it's pictured here on this yellow graph. The absolute value parent function faces up and is v-shaped, so we say the v opens up. The absolute value parent function has a left branch slope of -1 and +1. Let's go ahead and look at the graphs of some transformed functions. So first transformation is g of x. G of x has a coefficient of 5. We've multiplied the absolute value of x by 5. What that means is for any value of x, my output or my y-coordinate has been multiplied by 5. For x is 1, I went from 1 to 5. For x is 2, I went from 2 to 10. The effect of what we would call a large A, meaning a greater than 1, is that my graph gets steeper. So this green graph is my graph of g of x equal to 5 absolute value of x. My transformation is that I took the parent function and it's now steeper. I don't want you to think of this as skinnier. In fact, the more sophisticated way to describe this transformation is not steeper, but vertically stretched. I took every point on my graph and I stretched it vertically. So you can think of it as steeper or as a vertical stretch. Let's look at a second transformation, h of x. H of x equals 1/2 the absolute value of x. This is what we would call a small a fraction a, an a between 0 and 1. Now for any x value, I took my output, I took my y, and I multiplied it by 1/2. For x is 1, instead of having an output of 1, I have an output of 1/2. For x is 2, instead of having an output, a y value of 2, I have a y value of 1. That means that this is my transformed graph. When I have a small a, my parent function becomes flatter. The sophisticated way to describe that transformation is I have vertically compressed, I'm not going to say it's fatter or wider, I've vertically compressed my graph. So, parent function, big A, steeper stretched, little a, flatter compressed. Another transformation that can occur is I can have a negative coefficient, either just a negative, so an invisible -1, or a negative coefficient other than -1. What happens here is that instead of my v opening up, now my v opens down. This middle one is the graph of f of x equals negative the absolute value of x. I've taken every point on my parent function and I have reflected it over the x-axis. So just like vertical stretch, vertical compress is the sophisticated way to describe these two transformations. Reflecting over the x-axis is the sophisticated way to think about a negative a coefficient. It's okay to say, though, it's upside down, or the v opens down. By reflecting over the x-axis, I took any point, and I used my x-axis as the line of symmetry, and I reflected over it. Now, combining that reflection with my other transformations, I can have I'm going to say large A, meaning large in absolute value, and this will again be steeper. So k of x equals -5 absolute value of x is reflected over the x-axis, and because that 5 is big, I have a steeper graph. So -5 is bigger in absolute value, and so I have a steeper, a vertically stretched graph. If a is small in absolute value, as in L of x equals -1/2 absolute value of x, I have two transformations here. So I've reflected over the x-axis and my graph is vertically compressed. It is flatter. If we look at g of x and h of x above, the green and the blue, only one transformation has occurred. The g of x, the green function, is steeper, it's stretched. H of x, the blue function, is flatter, it's compressed, one transformation. If we look at j of x, also one transformation. Just negative absolute value of x, we've reflected over the x-axis. K of x and L of x, however, have undergone two transformations. First, they've been reflected over the x-axis by that negative sign. And then big A, vertically stretched, same as steeper. Little a, flatter or vertically compressed.